Hi everyone, in this video we're asked to determine an equation for the linear relation below, and we're asked to write our answer in y equals mx plus b form and in standard form. And this is actually called slope y-intercept form because m is the slope and b is the y-intercept of our line. So in order to write our answer in slope y-intercept form, first we need to know what is the slope and what is the y-intercept of our line. Now, because we're told this is a linear relation, we can figure out the slope by looking at the finite differences. We know that the slope is equal to the change in y over the change in x. And this is the same as the rise divided by the run on the graph, or y2 minus y1 over x2 minus x1. When you compute y2 minus y1, well, that's really just equal to the change in y. When you calculate x2 minus x1, well, that's really equivalent to the change in x. So we're really just calculating and using the exact same formula here. So let's go ahead and we'll look at the finite differences. When x increases by 2, so when we have a change in x of 2, positive 2, let's see what happens to y. Well, y decreases, so our change in y would be negative 1. So when x increases by 2, y decreases by 1. So our slope is equivalent to negative 1 over 2. The next thing that we're tasked with determining is what is the y-intercept. So what is b? So we can take, we know so far that we have y is equal to negative 1/2 x plus b, where I've just substituted my slope into the equation of a line. And we can substitute one of these coordinates, so we can substitute, let's say 1, 5, and we can do this to solve for the y-intercept. So we have that we're substituting 5 for y and 1 for x. And so we have 5 is equal to negative 1/2 times 1 plus b. Negative 1/2 times 1 is just negative 1/2. So we have 5 is equal to negative 1/2 plus b. 1/2 can be added to both sides of the equation to isolate for b, and we have that b is equal to 5 plus 1/2. So we have that b is equal, or 5 plus 1/2 is equal to b. Now, in order to add 5 and 1/2, we need to find a common denominator. We can rewrite 5 as just 10 over 2. So b is equal to 10 over 2 plus 1 over 2, which would be 11 over 2. And thus we can say, therefore, the equation in slope y-intercept form, therefore the equation in slope y-intercept form is y is equal to negative 1/2 x plus 11 over 2. Now that's not, we haven't answered the question completely because that's not the only thing that the question asks for. The question also asks for us to write our equation in standard form right here, in standard form. So in order to do so, we want to write our equation in the form ax, so standard form is written like this. Standard form is in the form ax plus by plus c is equal to 0, where a, b, and c are all integers and a is positive. So we have a, b, and c being all integers, and a has to be positive. So in order to have a, b, and c being positive, let's look at our equation here. Right now we have y is equal to negative 1/2 x plus 11 over 2, and we've got two fractional coefficients. So we need to somehow get rid of those fractions. And the golden rule when manipulating equations is that anything you do to the left side of the equation, you also have to do to the right side of the equation. So let's go ahead and we'll multiply both sides of the equation by the least common multiple of the denominators, and that'll clear our fractions. So we have the left side will multiply the left side by 2, and then I have to multiply the right side by 2 as well. If I do that, I have 2y on the left side, and I distribute 2 into the right side, or into the brackets here, and I get that 2 times negative 1/2 x would be negative x, and 2 times 11 over 2 would be positive 11. We can now rewrite this equation so that x has a positive coefficient by adding x to both sides of the equation. So I would have x plus 2y, and then I need 0 on the right-hand side, so I will subtract 11 from both sides, and that would give me x plus 2y minus 11 equals 0. And so therefore, the equation in standard form is x plus 2y minus 11 equals 0.